that has brought us together today. And now, to officially begin the celebration of National Science Day 2025, I am pleased to invite our esteemed dignitaries to inaugurate the event by watering the plant. This act symbolizes the opening of our minds to new possibilities, new horizons, and new ideas that are essential for shaping the future of science and innovation. Now, I would like to call upon Akansha Nair from final year BSc to welcome the gathering.
A very good morning to one and all gathered here. Start your day with a wonder. May this science event ignite minds and shape the future. Today, we gather to commemorate the groundbreaking discovery of the Raman effect by Sir C.V. Raman, a milestone that not only brought India its first Nobel Prize in science but also paved the way for countless innovations. National Science Day serves as a reminder of power of science, curiosity, and its profound impact on shaping our world. Now, I welcome our respected president of today's event, Reverend Dr. Lurdu Prasad Joseph. Welcome, Father. Now, I would like to welcome our esteemed guest and resource person, Professor K.S. Malesh. Welcome, sir. I would also like to welcome our respected principal, Dr. Ravi J. Saldana. Welcome, sir. I also welcome Reverend Father Jnana Pragasam, our administrator. Welcome, sir. I welcome Reverend Father David Sagayaraj S., Assistant to the Rector. Welcome, Father. Now I welcome Associate Professor Mr. Nagraj Aras, HOD of Physics Department, Vice Principal Academic. Welcome, sir. I also welcome Mr. Ronald Prakash Kutina, Vice Principal Administration. Welcome, sir. Now I welcome Associate Professor Mr. Thomas A. Gunasheelan, IQSC Coordinator. Welcome, sir. Now I welcome Dr. Alphonsus de Souza, UUCMS Coordinator. Welcome, sir. I would also like to welcome Dr. Noor Mubashir, CA, PG Director, and Dr. Reena Francis, Controller of Examinations, in their absence. I would also like to welcome the distinguished dignitaries both on and off the dais, esteemed faculty members, dear students, and all the science enthusiasts present here. It is my privilege to extend a warm welcome to you all on the National Science Day 2025 celebrations at St. Philomena's College, Mysore. This event is organized by the PG and UG Departments of Physics in collaboration with the IQSC. We are honored to have a distinguished guest speaker, Professor K.S. Malesh, a renowned physicist and retired professor from the University of Mysore, who will deliver the keynote address. A special thanks to all the members of faculty of Physics Department, both UG and PG, for their enthusiastic and dedicated efforts in organizing this event. This year's theme, Explore the World of Science through Brilliant Ideas, encourages us to think beyond conventional boundaries and embrace innovations. Through today's engaging sessions, discussions, and much anticipated felicitation of Dr. Alfonso de Souza, we hope to spark curiosity and enthusiasm among all present. Finally, I want to give a warm welcome to all the wonderful students who are here with us today. I would like to extend a warm welcome to each of you once again. Let's make today a celebration of knowledge, curiosity, and a spirit of science. To conclude my speech, I would like to share a beautiful quote by Carl Sagan. Somewhere, something incredible is waiting for us to be known. Thank you.
Thank you, Akansha, for such a warm welcoming. I also welcome you on this prestigious occasion. Science is not just Science is not just about discovering the unknown. It's all about questioning the known. Now, I request Reverend Dr. Lurdu Prasad to enlighten us with few of his words.
Honorable dignitaries on the dais, members of the teaching faculty, and my dear students, good morning to all of you. I think all of you belong to the science stream, am I right? At least you have studied science somewhere, even if you don't belong to the science stream, isn't it? I only studied a little bit of physics and chemistry, mathematics when I was in high school, as I was studying at St. PHILOMENA'S High School, Mysore. Certain things that I studied, especially physics, question of movement of light and sound, I still remember all those experiments that were conducted in the classrooms and in the labs. Today, as we celebrate the National Science Day, we are here in our country, we all speak from the pulpits that we should develop scientific temper. Unfortunately, the trends today in our country, I think, is going the other way around. Superstitions, traditions, customs are presented as if they are scientific inventions. Yes, unfortunately, this is what is happening. I'm not referring to any particular people or race or religion. Even the most educated people, unfortunately, we need to have customs, traditions, no doubt about it, but the scientific temper, which begins with curiosity. If you don't have curiosity, well, you don't learn anything. Curiosity is the first step. We have come a long way. Today we are able to enjoy the benefits of modern science and technology because there are people behind. They worked strenuously. And today I think humanity as a community of people, civilizations were able to take immense benefit from the scientific inventions. We have to be grateful to all people who made those inventions. Today as we celebrate National Science Day in our college, I think today we are celebrating what is called as inventions of our people, of our nation. We celebrate, we salute them, and we want to express our gratitude to them. And here at St. Philomena's College, we should know we were the first science college in the pre-independent India, and you are here to continue that legacy. Should you not be proud of your roots of this college? Don't you feel that? We must take pride in it. We belong to that rich tradition of legacy in which that scientific temper has been kept alive all these years, and you are the ones who will keep them alive for the years to come. This is also a day in which we are here to express our deepest sentiments of gratitude to one of our stalwarts. For the last 37 years, we are 78 years young. Out of his 37 years, somebody who served his institution. And today is a day in which we have mixed feelings of joy and sorrow. We are here to celebrate his legacy, Professor Alphonsus, who served this institution for the last 37 years. And today he is completing 60 years. From tomorrow, well, you may not see him in the campus as much as we used to see here, but I think he has left a lasting impression in our institution, especially through his research work. We are here to express our gratitude and our appreciation to our Professor Alphonsus. And I appeal to all of you that at least some of you should be able to walk in his footsteps in the years to come. That would be the richest fitting tribute that we would be paying to such an illustrious professor as Professor Alphonsus. Today, as he completes 60 years, we are all here to express our deepest sentiments of gratitude. Also pray to God that the good Lord might shower upon him his choicest blessings, especially good health, peace of mind. I thank you. Have a wonderful day ahead. God bless you all.
Thank you, sir, for sharing few words with us. Appreciation is the highest form of prayer, for it acknowledges the presence of good whenever you shine the light of your thankful thoughts. Now, I would like to call all the dignitaries to felicitate Dr. Alfonso D'Souza, sir. Now, I would like to call upon Ms. Chandana S. Ma'am from PG Department to address the guest.
Good morning, everyone. It is with immense pleasure that I stand before you today to extend a warm welcome to our distinguished guest, Professor K.S. Malesh. Dr. K.S. Malesh is a renowned physicist and a former professor and chairman of the Department of Studies in Physics, University of Mysore. He is a devout teacher with an impressive 41 years of teaching experience, including 29 years dedicated to MSc classes. He has played a pivotal role in shaping the academic careers of countless students. His contribution to research and education are truly commendable. Having successfully guided 3 PhD students and 2 MPhil students and authoring 25 research papers, and 24 conference reports, and a book on mathematical methods of physics and classical mechanics published by Kuvempu University. Beyond academics, Professor Mallesh has been actively involved in various scientific and administrative roles. He has served as a referee for the prestigious Pramana Physics Journal, a member of Indian Science Congress, a member of UOM Committee for Development of Science in Schools, and a resource person in numerous refresher courses and workshops. His commitment to science education is further evident in his efforts to write and promote scientific knowledge in both Kannada and English. Along with academics, Professor Mallesh is an artist, a musician, and a theatre enthusiast, an excellent orator. His knowledge in Kannada literature is an inspiration to us. Sir, your dedication to the field of physics, your relentless pursuit of knowledge, and your inspiring mentorship continue to motivate young minds. We are truly honored to have you with us today. On behalf of St. Philomena's College, I extend my heartfelt gratitude and a warm welcome. Let us all look forward to an enlightening session with Dr. K.S. Mallesh. Over to you, sir.
ಫ್ರಂಟ್ ಬೋರ್ಡ್ ಒಂದು ಪಾಕ್ಲ ஒரு நிமிஷம் அப்படியே பார்த்துக்கோ போடாது பர் ஸ்டூடெண்ட் கரெக்டாக வரல போதும் இல்லையா
Hello, hello, hello.
Yes, sir.
Conference mail open ಮಾಡಿ display ಮಾಡಿ.
ಯಾರಿಗೆ ಸರ್
Your attention please. Before we proceed with the address by the chief guest, we have received a circular from the government saying that in view of the National Science Day being observed today, in every institution, the faculty and students need to take a pledge, oath. So timing also has been given, 10:30. Now we are late by 30 minutes. Doesn't matter. I request all of you to stand just for a minute. And this is the oath we are all supposed to take now. It's in Kannada. Try to repeat whatever I say. Pratigna Vidhi. Stretch your hands forward. ನಾನು ಭಾರತೀಯ ಸಂವಿಧಾನದ 51A ವಿಧಿಯ ಅನ್ವಯ ವೈಜ್ಞಾನಿಕ ಮನೋಭಾವನೆ ಮತ್ತು ವೈಚಾರಿಕತೆಯನ್ನು ಬೆಳೆಸಿಕೊಳ್ಳುತ್ತೇನೆ. ನಾನು ಪ್ರಶ್ನೆ ಮಾಡದೆ ಯಾವುದೇ ತರ್ಕ ಒಪ್ಪುವುದಿಲ್ಲ ಹಾಗೂ ಸಂವಿಧಾನದ ಮೂಲಭೂತ ಕರ್ತವ್ಯದ ಆಶಯದಂತೆ ಮೌಢ್ಯತೆ ಮತ್ತು ಅಂಧಕಾರವನ್ನು ನಿರ್ಮೂಲನೆ ಮಾಡಿ ಜೀವ ಜಗತ್ತಿಗೆ ಪೂರಕವಾದ ಬದುಕನ್ನು ರೂಪಿಸಿಕೊಳ್ಳುತ್ತೇನೆಂದು ಈ ಮೂಲಕ ರಾಷ್ಟ್ರೀಯ ವಿಜ್ಞಾನ ದಿನದಂದು ಪ್ರತಿಜ್ಞೆ ಮಾಡುತ್ತೇನೆ. ಜೈ ಭಾರತ, ಜೈ ಕರ್ನಾಟಕ, ಜೈ ಸಂವಿಧಾನ, ಜೈ ವಿಜ್ಞಾನ. ಥ್ಯಾಂಕ್ ಯು. ಬಿ ಸೀಟ್. ಸರ್,
Good morning, everybody. I hope you can hear those who are at the... I am happy to be here on the occasion of National Science Day. A very important day in the history of physics. As you all know, Sir C.V. Raman discovered what is known as Raman effect. So significant that he had decided on several issues. He had determined that he will not use any instrument made by any other country other than my own country. Secondly, he said that within the gadget that the country can produce, he will come out with a discovery which is not just limited to this country, which is an international or worldwide discovery. Thirdly, he was sure that he was going to get the Nobel Prize. And I think even before the Nobel Committee announced the Nobel Prize, he had booked his tickets. So such was the confidence of Sir C.V. Raman. On this day, we are celebrating the National Science Day. I remember Morarji Desai was born on 28th February. If you are born on this day, your birthday comes once in 4 years, unlike others. So Morarji Desai once said, when he was 76 years old, I am only 19 years old, because he was also born on 28th. February. Sorry? 29th February. Yeah, you are right. Sorry. How many months have 29 days? All months, right? So that was a quiz question to me. So it is 29th, not 28th, is the birthday of Morarji Desai. 28th happens to be the day on which Raman submitted his paper on Raman effect. This year, 2025, is also the International Year of Quantum Science and Technology. This is a talk as part of National Science Day, and I have clubbed it that let it be also the day where we are celebrating the International Year of Quantum Science and Technology. I have been introduced. I am still teaching in Regional Institute of Education. Let me tell you one of my hobbies, even before I open my lecture. I wish if you have any questions in physics, I am always ready to answer. At least even if it takes time, I will find out the answer and let you know. That's my hobby. So I welcome questions in physics. More because I want to get more knowledge in physics. So with these words, let me go to this International Year of Quantum Science and Technology. I request you, it is 11:05 or 11:07. I may take 1 hour 30 minutes. So kindly be patient till the end of this lecture because the future belongs to you. This year 2025 is regarded as International Year. I am sorry the printout is wrong. This is the logo of the International Year of Quantum Science and Technology. In June 2024, it was designated by the United Nations. So United Nations declared 2025 as the International Year of Quantum Science and Technology. Actually, in 2023 March, Mexico led this resolution in the UNESCO conference. It was Mexico which proposed this idea that 2025 should be regarded as the International Year. It is also to celebrate 100th year of development of modern physics. Quantum mechanics really got developed in the years 1925, 1924, 1926, etc. During those years, it developed so much due to many contributions. What is the aim of this celebration? Year-long worldwide initiative will be observed through activities at all levels aimed at increasing public awareness of the importance of quantum science and application. So that is the motivation. And I am thankful to St. Philomena's College and all the dignitaries, principal and rector for giving me this opportunity. My own colleague Nagaraj Aras is here, Dr. Sachin is also here, my student, and there are also Amal Felon who actually first requested me to be a resource person here. So many of these faces are familiar to me, although I might have forgotten their name, right? But I love to see young minds here because you are the future of the country. So I would like to take next 90 minutes to tell you something about this quantum science and technology, which will ignite curiosity in you. The only reason is I feel that we must follow Albert Einstein, who said that whatever you have learned in schools and colleges, what has been told to you in your college, has been due to the incessant effort of great many scientists. They have some of them have even sacrificed their life to develop science. All that is given to you not in raw form, in a very crystallized form. The best, the honey of science is given to you in the class so that you first honor it, accept it, make it your own, and one day contribute something to it so that you will pass on to the next generation. This is the motto behind the science progress, and that is the ambition of this International Year of Quantum Science and Technology. We are mortal, but whatever we do will make us immortal. So with this word, I will go further. So this is the, let us come to a brief idea of what is quantum mechanics. I hope there are also BSc students here, so that I will try to give a brief idea about quantum mechanics. MSc students are already familiar through some of quantum mechanics application, but let me go through this. It's a new theory of physics, also called as quantum theory, quantum physics. Came at the dawn of 20th century with the sun of 20th century rising in 1900, a new theory came, that is quantum theory. It was started by none other than Max Planck. Later others developed it. Its aim is to understand the physical world. What is quantum mechanics about? It is about everything that we see, right? The whole physical world is the domain of quantum mechanics. So it wants to study the physical world. It replaced classical or Newtonian mechanics. Newtonian mechanics that you have learned started in 17th century, it was there in 18th century, and it also ruled the physics kingdom in the 19th century. But by the end of 19th century, there were some incidents and there were some problems that made classical physics worry about how to solve them. So these problems led to new ideas and new theory, and quantum mechanics is that new theory. It has been successful so far. No other theory has replaced quantum mechanics. That is the greatness of these 2 centuries. 1 century is already over, 20th century. We are in the 21st century. Quantum mechanics has been so successful. Nobody has been able to find any flaw in quantum mechanics. Somebody has said it is incomplete. Somebody has said it is inconsistent. Who has said like that? Let us see who they are. So, how do we describe the physical world? As you can see, the whole physical world can be divided into 2 parts. The macroscopic part and the microscopic part. Macroscopic part is one which you can see, touch, feel, etc. So that is the macroscopic part. That part is explained by Newtonian mechanics. However, the examples are tennis ball, rocket, earth, etc. But there is microscopic world which makes the macroscopic world. Every object that you see is made up of microscopic objects. The strange thing about nature is, what you see as the macroscopic object is made out of microscopic objects. Macroscopic objects obey Newtonian mechanics, but the very basic elements which make the macroscopic object, the microscopic world, they do not obey Newtonian mechanics. So the members do not obey, but the group obeys the Newtonian formalism. That is something strange about nature. So let us look at some differences between classical mechanics and quantum mechanics. In classical mechanics, basic ideas are familiar to our common sense. Whatever you think, right, it is right in Newtonian mechanics. When I say think, it is not just thinking. You will be acting like this. I think almost all of you know how to ride a bicycle or drive a motorbike or even drive car. But while driving cars or motorbike, you don't use, suppose your friend is going, in order to overtake him or her, you won't use V equals U plus AT or S equals UT plus half AT square, right? You use your common sense, right? So that common sense that you have gained is nothing but Newtonian mechanics. So even those art students, they also have common sense, and some of the art students write better than us. I hope you agree. Your own classmates may be in art section, they may know better driving and riding of bicycle, and one of you may not even know bicycle riding. Please learn that as quickly as possible, being science student. The next other thing I always tell my students is to learn swimming also. Swimming and cycling are 2 things that you must know in your life or practice in your life. Any amount of study, theoretical study will not give you the knowledge of these 2. Anyway, So basic, but the ideas of quantum mechanics are opposite to our common sense. What you think is right is not right according to quantum mechanics. So isn't it surprising? So that is the beauty of quantum mechanics, or that is the peculiarity of quantum mechanics. Next is, stones are particles, light is a wave. I hope I need not explain. A stone is a particle. When your teacher told something is a particle, what did you understand by that? Can anybody tell me what is meant by a particle? Collection of atoms. Atom is also a particle. What is that particle? Suppose somebody asks you, a layman asks you, something you call as wave, something is called as particle. Tell me what is meant by a particle. What is your answer? Okay, the answer can be, a particle is a particle is a particle is a particle. Right? That is the best answer. Right? A particle can never be a wave, and a wave can never be a particle. Right? It's not like some army officer who went to Navy function and he was asked to describe about Navy. He did not know anything about Navy. So he said that, who told Army is Navy and Navy is Army? No. Army is not Navy. Navy is not Army. In the past, Army was not Navy and Navy was not Army. And in future also, Navy is not part of Army or Army. Finally, Army is Army, Navy is Navy. Right? So I am not telling it that way. A particle is a particle means it never behaves like a wave. That is the thing that you must understand. By that, still, what do we mean by a particle, right? So we are only telling that a particle is not behaving like a wave. Then what is a wave, right? That also matters. So these two questions are so important. 19th century people felt that a particle can never behave like a wave. Let me tell you, one of the properties of a particle is, if a particle is here at some certain time, it cannot be here at the same time. Don't you think so? A particle always exists in one place at one time. Whereas a wave, if you have gone to a sea, a wave extends from left to right, right? If somebody asks you where is the wave, you will say here is also wave, here is also wave, right? Wave is everywhere. So there is that main difference between particle and wave. That is why, can you see a particle extended like this? No, right? It won't extend and then contract and anything like that. A mass, such thing as a stone will never behave like that. So according to quantum mechanics, if you take the microscopic world, anything in microscopic world has both particle property and wave property. That is something surprising, right? So that is why quantum mechanics is a new theory. Position and momentum are both certain in Newtonian mechanics. Please concentrate here. When I am saying I have a mouse here, I have kept here, its position is definite and it is at rest. So velocity is zero, momentum is zero, position is so much. So position is there, momentum is there, both are certain. However, in microscopic world, if there is an object, if you know the position, there is no momentum. And if you know there is momentum, there is no position. This is the correct position. So something which has a definite position has no definite momentum. While classical physics says both are certain, quantum mechanics says that if one is certain, the other is uncertain. You should not believe what I say. I will show you that it is something true through some idea. Physical world is deterministic according to Newtonian mechanics. What does that mean? That means if there is a subject here, an object here, and if you push it, if you know the form and if you know the initial position, you know where it will be later. So exactly you can determine where the system goes after some time. And if you measure there, it will be there. Right? That is what is called as deterministic. It is also called Laplacian determinism. However, quantum mechanics says physical world is probabilistic. You cannot tell whether something happens exactly like this. So you may say that while I toss a coin is a macroscopic object. I am still seeing many of you. You are not concentrating on my whatever I am teaching. Please, that lady there, exactly that lady, neighbor to you. Yeah, can you raise your head? You are not listening to me, you are talking. Don't hide your face. If you are honest, you say, I will not do, I will continue to listen to you. Please don't do that. I have come with a hope that you youngsters are our promise. You are going to build this country. Otherwise, we are the consumers. We only take everything from society. What have you given to the society so far? Please think about it. You want to buy this, you want to buy that, you want to buy this. What is that you have given back to society? Maybe this is the time when you are when you want something from society. When will you give something back to the society? Right? That's what Einstein wants. So if you don't like my talk, please go out. But don't, I can see the face now, don't repeat the same thing again. I am hurt by your behavior. One person can spoil the entire group. Please don't do that. I am unable to walk. Still I accepted this because I wanted to teach you youngsters that you have a responsibility. I hope you understand. Physical world is probabilistic. Even classical world, it is probabilistic. When you toss a coin, are you sure whether it will fall head or tail? No. Why? That is because you don't know what is the force you gave, what was the wind resistance and all that, you don't know that. Right? That is why ignorance brings in probability. But if you knew everything about the coin, the force, the wind resistance, you could have predicted the result of the coin. So probability is due to ignorance in classical world, but probability is intrinsic in quantum world, which means it is present there, whether you like it or not. Measuring devices don't affect property. When I want to measure the mass of this mouse using a balance, will the mass change? No, if that happened, then it would have been a very surprising thing. Your mother wants you to bring butter from the shop, and you go and ask for 500 ml of butter, and he will give butter. Suppose you come and you measure, it becomes 300 at home, then things would be different. You would go and quarrel with the shop owner. That does not happen. At best you may have 301 or sometimes 310 or 295 or so. Within some error the mass remains same. So measuring devices don't affect. Actually they affect, even in Newtonian mechanics. When you dip thermometer into water to measure the temperature of water, you are not measuring the true temperature of water, because the heat of the water is given partly to the thermometer. Now you are measuring thermometer plus water temperature. Am I right? So that is not the true temperature of the water. But you can build, in Newtonian world we believe that we can build an instrument which can make exact measurement of that. That is our hope. However, in quantum mechanics, measurements disturb the behavior of the system. How is that? So properties are affected by measurement. System assumes one configuration at a time. That's what I said. If there is a particle, it is here at 10 o'clock, means it is here. But at 10:05 it may be here. But at 10 o'clock it can't be here and it can't be here also. Two places, right? Wave can exist like that. Many configurations at the same time. Measurements respect locality. This is something which I hope even in your master's degree you will not be told. So I have listed it. It was a later combination. Only in post-MSc courses you may learn what is locality and what is non-locality. Learning later, but understanding can be done at any stage. Locality measurements respect locality means, suppose I do something here. I am giving my lecture here. My wife is not disturbed at home. She is far away, right? At least 6 kilometers away from here. She won't be disturbed. Right? Suppose I am doing something and suppose the water starts boiling there, right? Even she has not opened the stove and lit the stove and she will be wondering. And she may want me to continue giving lecture so that she can cook better, right? So that does not happen. Locality means whatever you do at some place will not affect the faraway place, not the nearby one. Suppose you have a stove here and you are heating and by the side you keep the butter, the heat gets transferred and the butter will melt. So locality means if anything done here will affect slightly neighborhood, not the faraway region. Assume that there are Martians, there are no Martians, right? If there are Martians, if they do some experiment, I don't think we will be affected on Earth also. So that is the meaning of that. Is it so? In quantum mechanics, measurements cause non-local effects. We will come to that. That's a nice concept. So the path breakers of quantum mechanics, Max Planck started in 1900. What he said was, electromagnetic energy is absorbed by system or released by system in packets. This is the statement which Max Planck said. Sometimes we understand when we write the same, what did Max Planck say? We will say that electromagnetic energy comes in the form of packets. No. He did not tell like that. I repeat, he said that systems accept or reject energy in terms of packet. What about the electromagnetic energy? That is continuous. Did you understand the difference? There may be water. I take always 1 cup or 2 cups. Does that mean that water exists in only 1 cup, 2 cups, 3 cups like that? No, it is continuous. However, later it went to Einstein who said that no, electromagnetic energy itself behaves like particles, small packets of energy, using which he was able to describe photoelectric effect and got the Nobel Prize for that. What is surprising is, by that time he had found out 2 great theories, special theory of relativity and general theory of relativity. The Nobel Committee did not honor him for those great theories. He was given Nobel Prize for this experiment and they simply said the Nobel Prize is given for this photoelectric effect and also for this great theory. So it was addendum. And then Rutherford came who gave the nuclear model. You must be surprised. Please read The Physics of the Atom by Richard Weher. That book gives you a wonderful history of how the nucleus was discovered. Even the discovery of neutron by Chadwick. Neutron is a very silent particle, doesn't have charge, right? Protons, electrons have charge, they get be deflected by magnetic field, but neutrons don't have charge, they are so inert. How could they discover a particle like neutron? Right? It was discovered by Chadwick. That itself is an interesting story. If you were assigned to discover neutron, how you would have done? May I ask you a question? How can you show that Earth is round? How can you show that Earth is round? How much money you need to show that Earth is round? Any answer? The question is whether Earth is flat or round. Round. You have been told like that. Your brother or younger sister wants you to tell me, show me that Earth is round. Don't show in TV or in graphic. Practically, how do you show that Earth is round? Anybody? Any answer? How much money you need? I think here is an answer. He says, go around in an aeroplane. Am I right? You must talk loud. No answer. You all believe that Earth is round. Belief should not be, Father was telling that you must not have blind belief. If you believe that Earth is round without any proof, then that is a blind belief. Right? You are not science student. Am I right or wrong? In science you must experiment and believe. Why do you Earth is going around sun. Earth is attracted by sun, still Earth goes around sun. If something is attracted, it must fall to sun. But it is going around sun. How can it happen? Why did you accept your teacher? Tell me the answer. This was told you when you were in 8th standard, and maybe some of you are in MSc. This is the first question I put to MSc entrant. Tell me why the planet goes around the sun. Any answer? Somebody is telling centripetal force. Centripetal force is the name given to a force which makes a body to go around in a circle. So how many forces are there on Earth? Centripetal force, gravitational force, centrifugal force. I think you have heard all the three. So all the three forces are there. But nobody tells, when you are asked, you have written, Earth planets go around sun because of gravitational force. Why did you not write centripetal force? If your younger brother or younger sister asks you this question, you will only say, no, these are silly, don't touch, this is already known. Known to others, not to you, right? That you must accept. If your brother or younger sister is smart, they will say, do you know the answer? If you know the answer, tell me. Otherwise, don't try to discourage me. Am I right? So none of you know. You are in MSc, you are in BSc. How is that you don't know? No answer. Then why are you learning nuclear fission? I mean, that is something too advanced. You don't know how a planet moves, and you are learning nuclear fission. I am sorry I have to talk directly because you should have asked your teacher in 8th standard. Why are the planets going around the sun? If that teacher had not answered, you should have asked your BSc teacher, MSc teacher. I hope if you don't have an answer, please go back and search the literature and find out the answer why the planets are going around the sun. Right. Yes, any answer? Louder, please.
Space-time fabric, sir.
Huh?
Space-time fabric. Space-time.
Oh my God, you are using big Einstein's theory to tell this. You may be right, but what is the simple answer, right? At high school, what do you tell them? If you say space-time fabric, I think the students, youngsters will not understand anything. You can explain it using Newton's theory of gravitation. Right? That's what I mean. So Bohr gave the atom structure. Right? If you pass light through prism, you will get continuous light. But if you heat hydrogen, hydrogen also sends light, and put a prism, then you will get line spectrum. So why line spectrum? Bohr said that I will assume circular orbits of definite radius. So from one definite radius to another definite radius, when the atom de-excites, then there is a particular line, therefore spectral lines are discrete. Then came Frank and Hertz. You may be doing Frank-Hertz experiment in the lab, right, to find out, discrete levels in atoms. They supported Bohr's idea. And then came Arnold Sommerfeld, right? He has written two great books, one on optics and electrodynamics. Please read those two books. Wonderful books. They are old, but they are treasures for physics students. So this man said that no, not circular orbit, but elliptical orbit. Anyway, I will go quickly. Then came Meghnad Saha, an Indian, who gave heat equation and whose theory also helped learning quantum mechanics. Then came de Broglie. This is one person who really contributed something major, more philosophically than scientifically. I think if I look at what he said was, if light can behave like particle and wave, matter also behaves like particle and wave. This was his idea. So I will show you a video here. The first is I have copied from internet. I wish one of you becomes an expert on video, designing, and there are thousands of experiments which you can design using your idea. Right? I have copied because, so this is when particles are passed through double slit. So they will get haphazardly placed. If a wave goes into the double slit picture or slide, it will see, right, both the holes and form interference fringes as you saw that. But suppose you set a quantum object. A quantum object is an electron. You don't know whether it's a wave or a particle. Now it is a wave, you are not observing it. When it reaches the screen, it is seen as a dot. So it is detected as a particle, but when you don't see it, it is a wave. Right? That is the picture of an electron. You see how electrons, they form, right? They fall onto this, but they also behave like waves. Right? So this is the first experiment which suggested that particles also behave like waves. Right? Then suppose you want to see through which door it is going, then that wave property is lost. So you are watching the electron going there. So it is to the left now. Can you see somebody is watching there at the gate? So if you do this experiment, then the interference, the fringe pattern is lost. If you know the path, there is no interference. If you want the interference, then you should not know the path. So these are the two. If you want to have something like you can have this, but you cannot have this. If you have this, you don't have this. That is the problem with. So the next person is Satyendranath Bose. He gave an idea, statistics with which Planck's formula could be derived. And later, he also found out theory of Bose condensate. He sent his paper to Einstein, and Einstein and Satyendranath Bose both wrote the paper, and that paper got published in their name. So Higgs boson is also named after this. Peter Higgs and this SN Bose. Wolfgang Pauli, he did the quantum mechanics for many things, and his famous principle is the Pauli exclusion principle. If you have two electrons, they cannot occupy the same state. In helium, there are two particles, two electrons. They are occupying K shell only. Then helium is disobeying Pauli exclusion principle. Do you understand my question? Pauli said that two electrons cannot occupy the same state. But in helium atom, there are two electrons. They are occupying the same shell. So are the electrons disobeying Pauli? Opposite spin, nice answer, right? Shell contains two states. Shell is one, but states are two. One has one spin, the other one has the other spin. So one electron will have spin up, the other one will have spin down. Nice answer. I am happy one of you gave the answer. I wish, please don't mistake me for asking questions and telling that I will be serious about my lecture. You are our hope, you are our light. That is why I have come here. I am a retired person. I retired 5 years ago, but still I teach in regional institute. What a wonderful students I have. They every day make me think about. I have to do a lot of work at home. I have, I think, 28 slides. I may be in the 5th or 6th slide. So those of you who are thinking, when will this end? It's a disappointing thing, right? I am still in the 5th or 6th. So please, just concentrate. Then came Heisenberg. Heisenberg is student of Niels Bohr. He came out with a formalism, quantum theory he gave. See, quantum ideas anybody can give. But to put it into a form of theory, you need some assumptions and principles. Heisenberg gave it. He obtained a formalism for quantum mechanics using matrices. That he did not know about matrices. Somebody told him that what you are doing is nothing but a matrix. You know matrix multiplication. Heisenberg did not know matrix multiplication. He went to the library, but on that day the library was closed. He was to wait till the opening on the next day, and he was there near the door 1 hour earlier in order to see the book where the matrices were present. So that is, next is Schrödinger. You learn Schrödinger's quantum mechanics. Schrödinger found the operator formalism of quantum mechanics. Both were students of Niels Bohr. Bohr would have felt very happy because these two people got Nobel Prize. He got Nobel Prize for another thing. Next person is Max Born, who helped Heisenberg saying that what you are doing are matrices. He helped Schrödinger saying that your wave function, if I take mod square, it means the probability of finding something that is clear. Because Schrödinger's wave function, Schrödinger's equation is a complex equation. See, complex equation, our real world is real. Why complex equation for a real world? It's a natural question one can ask, is it not? Is there any imaginary part for this chair? No. That question looks meaningless. What is meant by imaginary part of a chair, right? Everything is real for us. We say its mass is real, weight is real, its angular momentum is zero. So, complex equation for physical reality, the meaning of complex wave function was given by Max Born, who said that take the wave function, multiply by its complex conjugate, it becomes psi into psi star. Psi into psi star is mod psi square. That gives the probability of finding the system. So that is how probability comes into the picture. Then came Stern and Gerlach, who said that electrons have spin. And then Hallenbeck and Goudsmit, who said that theoretically they found spin. First one found experimentally, second one found theoretically. So it is P.I.M. Dirac. This man was the most intelligent physicist. What he did was, in 20th century, two theories came. One is quantum mechanics, other one is the special theory of relativity. Who gave special theory of relativity? Einstein, right? P.I.M. Dirac combined both of them. He said that suppose an object is very small, I have to use quantum mechanics. Suppose an object is moving very fast, I have to use relativity. So if an electron is going very fast, I have to use relativistic quantum mechanics for both of them. And he gave that theory, relativistic quantum mechanics. He gave an equation, and it's also called Dirac's equation. This person is Sir C.V. Raman, in whose memory we are celebrating today as the National Science Day. He found out Raman effect. Raman effect, let me tell you that we don't have a tabletop experiment of our own scientists in India. Raman effect has led to 20 different branches all over the world. There is laser Raman spectroscopy, coherent Raman spectroscopy. So Raman vibrational rotational spectroscopy. There are various branches. In India, we are not doing much about it. That's, I don't know the reason. We don't do Raman effect in the lab. That is the only experiment in India which got the Nobel Prize. And we don't do it. We don't know how to do it. If one of you can take the pledge that one day I will design a Raman effect experiment, which can be done in any degree college, that will be a great contribution. I think Karnataka government will award you specially, right? I hope one of you take up that. So you may ask me, what did you do, right? I can only say, I am a theoretical physicist. I am not a practical physicist. Dr. Sachin is also my student. We learn only theory. We learned only theory. So those of you who are good in, there are two branches in physics. How to choose your future. Decide whether you are very good in mathematics, then go for theoretical physics. If you are very good in designing experiment, go to experimental physics. don't have the designing ability and come to theory, or knowing all mathematics, don't go to experiment. This will be round hole, square peg in a round hole or something. These 7 people have contributed to quantum mechanics. I think I have told about Saha, Bose, Raman. Yes, Chandrasekhar here, who is in the middle, what he did was very extraordinary. He was awarded the Nobel Prize 50 years later. Right? There is a drama which is played in Mysore under the name The Square Root of a Sonnet. That is the life history of Chandrasekhar. His teacher openly tore his paper, openly blamed him for saying that his physics was wrong. But the student never, became angry at all. That is the country, that is our nation. We are so patient, we are so calm. It is our patience and calmness. We may be slow, but we are to be determined about something. You should have aim, right? So that he got his Nobel Prize for 50 years earlier. He was so fond of Shakespeare, right? That is why the drama is named Square Root of a Sonnet. Sonnets are written by Milton and other people, right? So next is Homi Jahangir Baba. This person you must always remember. In future, if nuclear power gives us the power, the father of nuclear power in India is Homi Jahangir Baba. He was extraordinary because he was both a theoretical physicist and an experimental physicist. I don't know whether you have seen Baba Atomic Research Center or Tata Institute of Fundamental Research in Mumbai. If you have not seen them, please go there. Have a trip to these 2 institutions. Once you go there, you will dream that when will I join this institute? If at all you want to become a scientist, the best places that you can go are these 2 institutes. In addition, you have IITs and other places. One thing that attracted me in TIFR was the hotel, the canteen, where if you are an insider, if you are a TIFR fellow, you are charged, I think, only 25 paise for one dosa. For an outsider, they charged me 25 rupees or so. So you can look at the discount. If you are in TIFR, you will get the best food. The whole building is AC. You might have AC in your college in a hall like this. The entire building is AC, even at that time. Whatever research paper you want, very next moment it will be on your table. Right? That is the level with which they respect the researcher. So if at all you must want to become a researcher, go there, have such a dream. There are great scientists in that institute. Let me be frank with you, I did not apply for that because I knew that I don't match with their intelligence. But I hope that some of you will go there and brighten this country's future. So some basic ideas of quantum mechanics. All systems have particle and wave property. Wave nature of light is known. Electrons also. Let me show you an experiment which is an actual experiment. This was done. See, 2-slit experiment where electrons are falling. So you can see that electrons are going through 2 slits and they are falling. This was done much later, maybe in 1970s or 80s. So this experiment shows that if you look only for a short time, they are like particles. They are coming and falling on the screen. But if you look for a longer time, so watch it, at the end of this, you will see that there is some pattern. Can you see the fringe-like pattern? So this is the actual experiment. Earlier was an animation. This is an actual experiment that proves that electrons also behave like waves. You just imagine they are sent through 2 holes, right? And they come out like this. So for example, devices affect property. Suppose you want to measure the position of this. Then how can you measure the position of this? First of all, you need light. Is it not? You have to see it. Without seeing in the dark, how can you find the position? No. You see the light. But will the light displace this mouse? Light falling on displaced is more. Imagine a situation when you were young, we were fascinated by aeroplanes going in the sky. Imagine if you looked at it, the aeroplane suddenly changed its direction, then what a great damage it would have done. One which I should have gone to Madras or Chennai would have gone to Andhra Pradesh. Right? If you looked at it and suppose it changed. Thank God that is not happening. You know this? The light that we see is incoherent. If it is coherent, I could not have seen you. I would have seen your fringes, not you. Imagine. So, is nature built for us? That's a question you can ask. Is nature built exactly for us? We don't know, right? So, light is incoherent. Sometimes we say, at least when I was a student, I was thinking that coherent light is really very nice compared to incoherent light. Incoherent light behaves randomly, whereas coherent light is like soldiers marching. So there is some discipline in coherent light. If this light was coherent, then I would not have seen you at all, right? So something great. Even the detector, light detector is our eye, is it not? Eyes detect light. You can see images because of light. These two instruments, they serve you for even 90 years without getting affected. For some people like me, 40 years I have to use this. But most of you will have good eyesight till 90 years. Which instrument in our lab works for 90 years without repair? So that is the duty of nature. I hope you agree with me. So probability governs the physical world. Look at this phenomena. Here silver atoms are sent through a magnetic field. If you send them through a magnetic field, some of them will come out as red, some of them will come out as black. Actually, they come out as spin up and spin down. I have written red and black. How many have come out as red? 5. How many have come out as black? 5. Next one, what will happen is the question. Will it go out as red or black? Are you sure? No, you can't be sure. You can only say 50% chance is there. So probability is inbuilt with this. So here is an experiment which does precisely another animation how, right, a classical magnet behaves, how a quantum magnet behaves. So classical magnet, if it is horizontal, it will go to horizontal portion. It gets distributed throughout. So this is the behavior of a classical system. But let us consider an electron. So how does electron, if you send electrons, how does that behave? So it goes something like this. It will go either up or down. Again, this is a video coupled from the internet. I have not done this. This experiment revealed the existence of spin. How is that? There is no in between, either up or down. So this is what is the spin angular moment. Next, properties change under measurement. Let me take the same experiment which you saw and through this, right? So you can show that properties are also affected. So quantum mechanics began with this idea and it led to technology also. There were questions at fundamental level, they remain unanswered. One theory whose basis was not very well founded, still it developed like anything. Anything people did in quantum mechanics, we have new discovery and new paper, right? So what it led to? It grew and it led to new technology. Transistors came, integrated circuits came, microprocessors, calculators, computers. From computers to supercomputers, they were all built. I wish to tell you that in Mysore, there is a scientist who wishes to tell you how to design a supercomputer. He has already designed a supercomputer and he is settled in Mysore. Are you interested? I can give the details of that person to you. Please, Dr. Sachin, invite that scientist. he can tell you, if 5 or 6 of you join together and meet him, he will tell you how to make a supercomputer. I am not telling any lie. He has already built one supercomputer. Maybe its name is Param or something like that, I don't know. But when I last talked to him, he said that, Malay, nobody is interested in designing computer. I am ready to guide students who can make computer. Right? Either girls or boys, no matter. Please, if you are interested, go there and build one supercomputer. Some 5 students of Mysore have built a supercomputer. If that is the news one day in the newspaper, I think Mysore will be very proud of you. So I wish, his name is Professor N.D. Haridhan. He lives quite nearby. So you can one day invite him and do that. So classical computer work in according to what is called a classical Turing machine. Computation is done. How do you do computation? Suppose you want to send 12 as the input. So 12, the number 12 should be the input. So this 12 is converted into voltage. How voltage is decoded as 12 or 12 is decoded as voltage? 12 in binary can be written. Can you help me? How do you write 12 in binary? 1 1, very nice, 1 1 0 0. 1 into 2 power 3 plus 1 into 2 square plus 0 into 2 power 1 plus 0 into 2 power 3. That gives you 12. So finally 1 1 0 0. That is how you decode 12. Now take electric circuit, raise the voltage to 1, feed it, that is first one. Again feed another pulse which is also 1 volt, that is another one. Next feed 0 volt, you have fed what? 1 1 0 0 to the system. So but here you are feeding one by one after the other, right? One behind the other, 1 1 0 0. You cannot feed directly all the 4, or you cannot feed something like I will feed 1.5 volts, so something like both 1 and 0, no. It's either 1 or 0, classical bit. They may be modern quantum computer, my own laptop, your own mobile, they may be quite modern, they may be 2025 February 27th model, right? But even that is a classical logic machine. It has become very fast, but still it is a classical logic machine. Classical logic machine means what? It will take 0, 1, etc. one after the other, right? First 0 goes process, then 1 goes process. Can you process something like this? There are parallel computers which do that. Supercomputers have that ability of taking like this, all the 4. This will, see, if you take this and do something, next take this and do some other thing, what you can do is this, you feed this to 4 different computers. Let this do whatever it wants to do to first one. Are you following? So all these are later combined and that is called parallel processing. But that is still classical computation. But technology has been in advance. So what it wants is things have to become smaller and also faster, right? Your own mobile, say 10 years ago was of one type. Now you have rejected it and you have got another mobile which was so faster. Not only small but also faster, right? So these are the two words. In the past, the computer was as big as a room. Present you have handheld devices which are much faster than the first computer built by Babbage. Then earlier we had mechanical calculator. I don't know whether you have seen a machine. We had a machine as MSc student. We wanted to multiply wavelengths, 2 wavelengths. So this machine was to have to rotate, right? So many digits into so many digits means you have to rotate 9 times and 8 times like this. So this was being done. Now you have computers which are fast solvers. Now, what do you want to make things very fast? If you bring things very small, then they will become atomic size one. So once certain things become atomic size, then quantum effects will appear. For example, the electric switch here is so big, it contains more than Avogadro number of particles, and what it does, it does only two actions, off and on. Now, can you not use one hydrogen atom to do on and off? When it is in ground state, it is off. When it is excited, it is on. Suppose we use a hydrogen atom, then that is a wonderful thing. But then hydrogen atom does not obey Newtonian mechanics. It obeys quantum mechanics. So, if at all you want to make things smaller, your system must obey quantum mechanics. Even speed-wise, there is a limit that you cannot exceed the speed of light in vacuum. More important than this is the time needed to solve a problem. Given a problem, you need certain time. For example, let me go to the next one. Let me take the third problem first. 17 into 19. How do you do this? You will first multiply by 9 and then multiply by 1 and then add, is it not? So this is how you produce the product of the two. Suppose you are asked to find the factors of 247. I think you can give this answer first than this answer. Is it not? What are the factors of 247? Which are the numbers which will divide 247? Can you find out? 2 will divide? No. 247 is an odd number. How can 2 divide odd number? Which are, how smart you are in mathematics? Right? Without writing on paper, can you tell me what are the factors of 247? Yeah, by that time at least let me drink some more water. I hope at the end of that you will give me an answer. Okay, 19 into 13 I think is the answer. What is 19? Please check in your mobile. 19 into 13 is 247. How many digits 247 has? 3 digits. Given 3 digits, you take at least 10 minutes to find out the factor. You have to divide and find out. Suppose my number has got 126 digits. 247 has got 3 digits. I have a number whose digit size is how much? 126 digits are there. Suppose I ask you to find the factors of that, you know how much time it needs? It needs millions of years. Millions of years. That is why in the United States that 126 digit number is used for coding your debit cards. Your debit cards are coded by using that 126 digit number. If it was 247, within 10 minutes you could have found out the factor. But that number is how much? It has got 126 digits. If you want to decode it, you need millions of years. So that is why your debit cards are safe. Unless you give the passwords to others, nobody can find that by themselves. I think I may need another 20 minutes, I will complete. I started at 11:10, Sachin. I will need at least 12:20. Please be patient. I will go quickly. So there is a problem like 17 into 19. Multiplying is easy, but factoring is difficult. I want you to, just don't believe me, don't you think so? Factoring 247 is not so easy, right? It takes more steps, that's all. Next, suppose x is a function. See, x has got 2 values here. Can you see in the table, x takes 2 values. Suppose there is a function f of x. 4 types of function can be possible. What is that? F of 0 is 0, f of 1 is also 0. Then f of 0 is 1, f of 1 is also 1. Next, can you tell without looking there? F of 0 is 0, f of 1 is 1. What is the last one? F of 0 is 1, f of 1 is 0. These are the 4 possibilities you can think of. The first one and the second one have the same values, right? 0, 0, 1, 1. Such functions are called constant functions. The other one has values distributed. That is called balanced functions. Now, I give you x equals 0. I also give f of 0. F of 0 is 0. Is it constant or balanced? I give you only f of 0, which is equal to 0. I am asking you the question, is it constant or balanced? What is your answer? You should tell me. Please give f of 1 also, then we can decide whether it is constant or balanced. You know, if you are deciding even by one input, then you are better than 2025. You are already in 2040. So I think you are the best people, right, to do this one. I give you only f of 0. Knowing only f of 0, can you decide whether it is constant or balanced? No, you need also f of 1, right? So this problem needs two queries. Queries mean somebody has to give you f of 0 and somebody has to give f of 1 also. Then only you can find out whether it is constant or balanced. But I will come to that later. Classical computing has this problem. Suppose there is a telephone directory. Have you seen a telephone directory? Or, right, I don't know. You are so young that you might not have seen directories disappeared long ago. Earlier, BSNL used to give this size directory, where every phone number was there. Name, address, phone number was there. So, suppose the name is given, it was in alphabetical order. To find the phone number, is it not easier? Just go to that page, alphabetical page, and find out. For example, Shishi Kiran. You go to yes, and then look for Shishi Kiran, and right side you would have the phone number. Suppose I give the phone number and ask you to find out whose name is this. Then is it easy? Maybe it is the first number, or maybe it is the last number. So it takes so much of time to do. Searching what is the name of a given phone number. Searching what is the number of a given name is easier. But the other way is taking time, right? So this is another kind of problem. So there are problems which are called polynomial problem, and there are the numbers which are called non-polynomial problems, right? So non-polynomial, they are also exponential problem. So I will go quickly. Feynman gave a suggestion. He said that, I don't know, my mouse is not cooperating with me. Classical computers can solve polynomial problems. They can find if a number is prime or not. 101, is it prime or not? 111, for example, right? Is that number prime or not? Prime? Not a prime? What are the divisors? 3, right. You are right, very nice. 101? Is it prime? How do you know? From what value to what value you have to check? You have to first divide by 2. Anyway, 101 is odd. It can't be divided by 2. Then you have to divide by 3. You are finding this in your computer lab, I think. Sachin, you can sit. Why are you standing? Right? So, tell me the procedure. How to find whether a number is prime or not? You have to divide by 2, 3, 4, etc. Till what stage? Logic. Do you know the logic? I want to know whether 101 is prime or not. Then from what value to what value I have to divide? From 2 to? Are you doing prime number problem in C programming class? Yes or no? If you say yes, then you only by heart the program. You have not understood the program. If you are doing prime number program in C, then you are only by hearting the program. You have to check till what number? No idea. So how can I mean, when will you become more intelligent? I think your intelligence is not enough. I am honest about it. I should have got some answer from you, like 111 is 3 into 37. Right? The other person said 2 straight. What about the backside people? Front only are intelligent, backside are not? Don't be so. Tell me. From you have to divide by 2 and then 3 and then 4. Like this, for 101 till what number you have to divide? Louder. Yeah, till what number do you do that? Yeah, what is that logic? I think ultimately it is division by 2, 3, etc. only. No, you are telling about the divisibility of a number by 2, 3. There are some tricks. If a number is divisible by 9, to check it, you have to just add the digits and see whether it is 9. Right? You are telling about the divisibility of a number.
Yes, sir.
But to check whether a number is prime or not, suppose you want 101, you have to go at least to half of it. Something like 51. So if it is not divisible by 51, certainly it is not divisible by 60. How can 101 be divisible by 60? Please sit down, right? But it is not even that. It is enough if you go to the root of the number. What is root of 101? Root of 100 is 10. Root of 101 is slightly more than 10. So take it 11. It is enough if you check from 2, 3, 4, etc. up to 11, right? Don't you think that's an interesting thing? Given any big number, to find out whether it is a prime or not, what should you do? First find the root. If you don't get, if you get the decimal value, take the nearest next integer value. So from 2 you have to check up to that point. Okay, these are at least, if you can't understand my lecture, at least if you have learned how to find whether a number is prime or not, I would be happy. Right? So, however, the logical computers can find whether a number is, whether your answer is right or wrong. Right? So, solution can be found out. So, Richard Feynman gave 3 papers. You must read 2 of his books. One is where you are joking, surely you are joking, Mr. Feynman. This is autobiography written by Feynman. A crazy character. I think under that it is written, a crazy character. You will laugh at yourself. Was Feynman so crazy? He used to go to atomic bomb manufacturing unit and they would have put several codes and he would break the codes and enter and search all the shelves. He was not misusing. But whatever people thought was very secret, that was not secret at all to Feynman. He was so intelligent. So please read that book. Surely you are joking, Mr. Feynman. The other one is, what do I care what others do? What do I care what others do? A great scientist. You must read these 2 books by Feynman. So yes, he said that take systems that function according to quantum mechanics, subject their states to Schrodinger evolution, they can function as quantum computing system, they can do better than classical computer. Take hydrogen atom, use Schrodinger equation for this. Hydrogen atom is taken as input, Schrodinger equation interaction is the gate, and then you can solve any classical problem. A physics problem to solve a mathematical problem. What a wonderful thing. The idea is the physics problem or quantum mechanics can solve better than the classical computer. That is the thing. So let us understand what classical input is and what quantum mechanical input is. Classically, you say that something is 0 always, something is 1 always. But quantum mechanical qubit is of both color, right? It is partly blue and partly red. It can at the same time behave as 0 and at the same time behave as 1. Therefore, you are giving both the information to the system. Do you understand? So, whereas classical bit you have to first give 0 and then give 1. But suppose you send a hydrogen atom, you are giving both spin down state and spin up state. Another way in which if you can't understand bit and qubit here, qubit is quantum bit. That is the input according to quantum computing. So, bits means something in a globe, right? Something always points downwards. It will never change this direction. That is 0. That which always points up is 1, right? Whereas a quantum mechanical system, a spin can point in any direction. So this is a qubit. It is partly 0 plus partly 1. Can you not picture it like your vector resolution of vector? You have written r equals xi plus yj. Right? This is something like r, vector r is equal to xi plus yj capital. So this contains both the information of 0 and 1. If you don't like this, there is also light polarization. A vertically polarized light has electric vector vibrating in the vertical direction. Horizontally polarized light has electric field vibrating in the horizontal direction. If this represents 0, this represents 1. But suppose you consider circularly polarized light, it represents both 0 and 1. So, if you want to make a new computer based on quantum mechanics, use circularly polarized light. Classical computers are like using only vertical polarized or horizontally polarized. If you don't like this physical feature, mathematically how can you write? So, if you write 1, 0 as a column vector, it is state 0. 0, 1 as a column vector, it is state 1, right? So, that is, whereas a qubit is like A here, B e power I phi. For example, B equals 0, A equals 1 means it is this itself. So, the first one is 0, second one is 1. So, this is how classical computers work. Feynman said use the quantum system and they will work as qubit. They can do much faster the calculation. So, what is this state? This is called superposition in quantum mechanics. Superposition principle says that a wave function can be written as linear combination of two other waves, wave function. So here 0.6 into up plus 0.8 down means this quantum system is 36% in this state, 64% in this state. So it has 36% of existence in this state, 64% of existence in the other state. It has more information than the classical bit. So more interestingly, this is once again the same thing. If A is like this, you say it is 100% in this state. If A is like this, it is 100% like this. If A is like this, it is superposition. Partly here, partly there. Right. Next, suppose you have two particles. Two quantum bits. Then, if this is up, this is down, you know that 100% first is up, second is 100% down. Whereas here, it is 100% down, it is 100% up. Suppose they both of them are in superposition. First one up, second one down, minus first one down, second one up. This is a possible state of two qubits. Now if I ask you, if you look at this state, this is, what is the state of A? Can you answer this question? You can't answer exactly because according to the first part, it is up. According to the second part, it is down. So 50% up, 50% down. That is the behavior. So if two particles are in this state, they are called as entangled state. Entangled states have a property that if you do experiment on one, the other one gets affected. So let me tell you how the other one gets affected. In quantum mechanics, they use quantum computer Alice and Bob. Maybe because A and B are used. Alice is on Earth, Bob is on Mars. They have entangled system. Somebody prepared an entangled system. Bob took it to Mars and Alice is on Earth. Now, Alice opened the top door. Then Bob also opened the top door. If Alice is up, Bob sees it down. Right? Next, on the other hand, suppose the same thing, if Alice is down, then Bob sees it is bit up. So it looks like the second one is adjusting to the first one's behavior. But where are they? One is on Earth and the other one is in Mars. So something done here is affecting something done there. So the third picture is much more interesting. Alice and Bob, entangled state. Alice opens the side door. She sees in this direction. If Bob sees in the same side door, he will see it in the opposite direction. But suppose Bob sees in the up direction, sometimes he sees up, sometimes he sees down. So it also depends on which door you open in all these situations. So peculiar is the behavior of two particles which are entangled state. So peculiar that Einstein himself said, oh, I am unhappy with quantum mechanics. So he said that spooky action at a distance, some action is taking place at a distance, like in our films where a hero blows his hands and suddenly villain far away falls down, right, without any physical impact, right? Something is happening like this. So spooky means ghostly. If I do something here, some ghost in Mars is changing there. So he says that this is not physics. I can't believe this. So Einstein opposed quantum mechanics, said that it is either incomplete or it is inconsistent. I must tell you one thing. When Einstein gave theory of special relativity, the whole world took a lot of time to understand. The whole world. Eddington himself was so, when a newspaper asked him, how is that you are one among the three who know relativity? He was surprised. Einstein knows one person, I know second person. Who can be the third person? There can't be anybody. Only myself and Einstein. We only know, no others know of this reply. So Einstein makes a theory, the whole world stands in ecstasy. They can't understand. Even Nobel Committee does not understand whether to give a Nobel Prize or not. But then the whole world gathers. By 1926, Dirac and others made quantum mechanics a very strong theory. In fact, in 1926, Dirac makes an observation that by 1926, today is 2025, already in 1926, quantum mechanics had developed to such an extent that all of chemistry could be explained. All of chemistry could be explained. Most of physics could be explained. So in order to explain something remaining in physics, they had to go beyond 1926 quantum mechanics. So the whole world makes quantum theory, Einstein stands against it, alone. He says that I don't agree with this quantum mechanics. So that later Einstein was proved wrong. Bell came and said that this time. So Einstein questioned quantum mechanics because he said he believed in locality and reality. This is how he defined reality. I think there is no time. He wrote a paper in 1930. The paper contains about his conclusion that quantum mechanics is either incomplete or inconsistent. So, do we agree with reality? I have a question here for you. Do you think the world is real? Right? What is your opinion now? So, you think philosophically may not, because philosophically many philosophers say that world is not real, right? World is Maya and other things. I am not criticizing or commenting on a religion. But some philosophers have told one thing, other philosophers have told other thing. But science-wise, do you think life is real? So if you think life is real, here is an experiment. I hope you will agree one thing, your friend says no. I will show you a video where you think it is rotating clockwise, but your friend says anti-clockwise. I am not doing it. Let us see that. Just watch and tell me whether this cat is rotating anti-clockwise or clockwise. Change your eyesight and again see. I am sure you and your friend will not agree. Please ask her whether she agrees. So, you may think that it is, after some time it is changing itself. No, but I think two of you will not agree. You yourself will not agree after some time, because if you change your sight and look into it, it will change its sense of rotation. Am I telling correctly? Do you see that? Yes or no? Like a child, I enjoyed this. My eyes cheat me, right? Yeah, do you think so, right? So, at times it goes like this. You look at and again see, it will go the other way around, right? So, that is something. So, don't be thinking that everything is, your friend may not be friend in the next moment, right? like this. So be careful, life is not real. Well, there is Dash algorithm. This is first algorithm which shows that classical computation is slower than quantum computation. Here is a hydrogen atom or an electron. It is subjected to a magnetic field. It goes into superposition state. I have written the quantum mechanics of that here. If you do the quantum mechanics, you will finally can answer. Given only f of 0, you can tell whether f is from constant or balancing. That is problem. In quantum computer, in classical computer, you cannot answer that question with one query, but in quantum computation, you can do so with one query. Next came, that is the first Dash algorithm. Peter Shor algorithm found out how to factorize a given number. 126 digit number. Classically, how much time it takes? Millions of years. But if you use quantum computer, you can break it within minutes. Then your debit cards will be in danger. Right? If somebody finds quantum computer, then one can know what is the password, everything about your debit card. America is now worried. If somebody builds a quantum computer, so far it has not been built. You must treat it as a challenge and an opportunity. If somebody has already built, then you have no work to do. Right? So far nobody has built a tabletop quantum computer. The quantum world, or the world is waiting for you people. You are so bright. I hope you will do. One of you will take it. Grover's algorithm does searching problem, like phone number and this one. So if you give a phone number, it will quickly tell the name of the person. Quantum computation. So Lloyd also proposed a quantum theory. This is the first. You may be using Google's AI, ChatGPT and all that. Right? This is the machine which does the job in Google. So this is the quantum computer at present. It looks so big. Right? So big, beginners don't worry about size. So it is answering all your questions with the AI, ChatGPT. So this has got 105 qubits. So quantum computation is to solve a problem much faster. Next, quantum cryptography, how to code a message. So suppose you want to code a message as, say, save our souls. What is the Morse code for it? Say some people who go to mountaineering, they may get lost in the ice, this one. So they will not cry, save our souls. What do they send? Anybody? They will send 101. Save our souls. Yes, oh yes. Is sent as 101. So 101 is sent, suddenly the department will know that somebody is in danger. Right? There was a joke that once some 4 young boys were going in a train. There was a nice girl sitting opposite. So they were Morse code people. So one was typing how beautiful the girl is and all that. Right? Her father was also there. So the other boy was ready. Yes, she is so nice and all that. Finally, when they were about to get out, the father coded a message. See, if you had done anything more, I would have taken task to you. So he was also a code expert. So the students did not know about it. Anyway, right? So this is how to code a message. You can code a message so that nobody can decode. Classical coding can be decoded by others. Quantum coding cannot be decoded by others. Next is quantum communication. This communication, nobody can, I think everybody is going away. So I will quickly go through. So present breakthroughs, we have found out several items which have been great breakthroughs. And there are challenges how to make qubits and all that. So finally, let me tell you how much research has been done. According to the world statistics, India stands 5th from the right. First United States, China, Germany, India. India is in the 5th position in producing some good research. What about funding? And Indian government has given 6,000 crore. It has given. Central government has given 6,000 crore to develop quantum computing. If you go to IIT, Bombay, etc., those places, you can do research on quantum computing. ISRO has successfully demonstrated secure quantum communication between two ground states. So much has been already done. 6,000 crores is not a small amount. It is almost equivalent to our country stands, I think, 5th in the world. Almost same as United Kingdom, as a rich country has given money to the quantum computing world. India has also given so much of money. Things are taking shape everywhere. Quantum ideas are being researched and all that. I think I have come up to the end of this one. So the last, but not the least, is the future probably belongs to those who can handle uncertainty and make quantum jump. Hopefully, there is quantum mechanics. So that you can enter into quantum mechanics, learn it, very difficult to learn, master it, so nice. Don't worry about understanding quantum mechanics. First learn how to do quantum mechanics. That is easier than understanding quantum mechanics. When you start doing more and more, you will get to know what it is. Right? So with that, I thank, I knew only this. Principal Dr. Ravi J.D. Saldana and Dr. Amal Phelan, who first made a call to me and requested me to talk. And then Sachin took over and he did all the help to come over here. I'm sorry I was a bit not so considerate and calm, but that is because I hope that you youngsters don't be carried away by the fashion of the day. Vivekananda says, the flash of the brightening may be so bright, but it is only for a moment. Right? And secondly, a donkey in the lion's dress cannot become a lion. Right? You have to be a lion from inside. So let us not just borrow the ideas from the others and just let us not act accordingly. Let us build our inner strength and make this country great. Thanks to one and all for patiently listening. I also thank all the internet resources from where I have copied all these videos. Thank you. If you have any questions, you can ask.
Yeah, if anyone have any question, please, we have mic somewhere in between. Anyone want to interact?
Well, I can tell you, I have also done some work in quantum computing. I can tell you some basics of it. Right? I can come if some arrangement is made without any reservation. I can come here, say once in a week and tell you